be talking about Unit 7, Quadratic Equations, Day 2, Finding Unknown Inputs. Our focus question for this lesson is what is important to pay attention to when writing a quadratic equation that represents area. For this video, we will focus on going over the launch. I'll start off by reading the launch to you. As I read the launch, I'm going to annotate key information. You can also follow along and annotate on your screen, and Google Slides actually has some features that you can use to annotate. So you have this right here. This is you can draw a line. You click that, okay. A mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform of 20 feet above the ground. Well, that's an important number. I'm going to underline that. I'm going to actually use red to underline it so I can see it better. Okay, and then I'm going to underline this one right here as well. Okay, just going to make it red. Okay. With an initial vertical velocity of 92 feet per second. Also important information, it's being thrown up. Velocity means the speed at which the potato is being launched. So I'm going to underline that as well. Make it red. Okay. The function h of t equals negative 16t squared plus 92t plus 20 models the height of the potato over the ground in feet t seconds after launch. Here is the graph representing the function. Well, I'm definitely going to underline that function. Okay. And I'm also kind of thinking to myself, okay, when I see that function, I'm thinking, I've seen these numbers in the equation already. I see 20, in the word problem already, and I see 92. I don't see negative 16t squared, or just negative 16. Maybe think to yourself, what does the negative 16 represent, or the negative 16t squared represent in this situation? Think back to the previous unit. And here's the graph. So now we're going to take a minute and we're going to tell all you can about this situation based on the graph. And you can pull from the story as well. So if you haven't done this already, you can pause the video and take a moment to do that. Otherwise, we can jump right in. So tell me all you can. Well, the first thing I'm noticing is where it starts. The initial height of the potato is 20 feet. I can see that here. I can see that here. I can see that here. At 0 seconds, the potato starts at a height of 20 feet. Let's look at the graph and see some other key information. Well, I see that the potato hits a maximum height around 3 seconds. So I'm going to write that here. The potato hits a maximum height of around 3 seconds. The maximum height of the potato is, well, if you notice this is counting by 20s, 20, 40, 60, 80, 100, 120, 140, 160. It's about 150 feet. We don't really know exactly the maximum height just by looking at this, but we can guess it. Now I'm going to continue looking at the graph and I'm going to say, oh, well, the potato falls to the ground. Let's pick a different color. Sorry. The potato hits the ground at about, at about 6 seconds. How do I know that? Well, the height of the potato is 0 feet. So that means when the height of the potato is 0 feet, it has to be at the ground. So the potato hits the ground at 6 seconds. It can't fall any further because you can't have a negative height. These are key features of the graph, and these are key aspects of this story. We can also talk about, we know that the potato is being pulled down by gravity, right? Every object that, unless we're in outer space, that is launched into the air gets pulled down by gravity, and that's where we get that negative 16t squared. We can add the information from the story if we wanted to, right? The potato is being launched at a speed of 92 feet per second. I'm going to add this here. The initial height of the potato is 20 feet. Based on the problem, the potato is launched from a platform. So we can add that on here. The platform is 20 feet above the ground. Okay, there may have been other things you added here. You can even add in at 1 second, the potato is at about 90 feet. The turning point of the potato is at about 150 feet. You can add in at 5 seconds, the potato is at about 80 feet. You could have said the potato goes up and then down. That's fine. There's an infinite amount of things you could have written here. And we always want to just look at what are the key features on the graph? Where do I see them in the story? We want to look for the starting point, the y-intercept. We want to look for, right, that's the y-intercept right there where it crosses the y-axis. We want to look for the x-intercept or the 0. And in this situation, that's where the potato hits the ground. We want to look for the maximum, or in some situations there's a minimum. The maximum is also the vertex and the turning point. I'm going to add that here. Okay, so now if you haven't answered the questions on the next slide, you should go ahead and do that. But if you have, we'll go over them. So what is the height of the potato 1 second after launch? Well, it looks like it's at about 90 feet, maybe a little bit less. You could have said 86, you could have said about 90. So let's write that in here. The potato is at about a height of 90 feet. You always want to include units. It's not quite at 90, it's about there. 8 seconds after launch, will the potato still be in the air? Well, 8 seconds. Well, we know the potato hits the ground at about 6 seconds, so after 8 seconds, the potato is definitely not going to be in the air. Unless you shot it up again. No, the potato will not be in the air because after 6 seconds, because it hits the ground around 6 seconds. Will the potato reach 120 feet? If so, when will it happen? So I'm going to go to the height of feet, 120. Oh yeah, it reaches 120 feet at about 1.5 seconds. And because parabolas are symmetrical, it also is reaching 120 feet at about, maybe I would say 4.25 seconds. So it reaches 120 feet at about, again, 120 feet at about 1.5 seconds and at about 4.25 seconds. And again, you can kind of round and estimate because we can't know exactly when, because we know it's happening between 1 and 2 and then between 4 and 5. When will the potato hit the ground? Well, when the height is 0 at the x-intercept, which is at about 6 seconds. Okay, so you can compare your answers to this, and then you will next go into the Explore and build on what you learned further by exploring another quadratic relationship. Excellent work.